Hi there. Let's continue with section 5.3, division of polynomials. Let's begin with a divisor is a polynomial. To divide a monomial by a monomial, we divide coefficients, and if the bases are the same, subtract the exponents. So, for example, we have two examples here. This first one, we see that 63 divided by 7 is 9. And our exponents, they have the same base, so we subtract their exponents, top minus bottom, 8 minus 2. So we get this as an answer. Now for the second example, we can divide. Looking at the coefficients, 62 divided by negative 6, that gives us negative 7. Now let's look at the variables separately. For a, we have a 3 over a 2, so we have 3 minus 2. For our b, we think of this as an exponent of 1. We have top minus bottom, 4 minus 1. So that we get negative 7, a to the first power, b to the third power. We subtracted. 3 minus 2 is 1, 4 minus 1 is 3. So to divide by a monomial, divide each term by the monomial. So let's go ahead and rate this. So that we have 6a cubed b squared, and we're going to divide by a monomial of 2ab. So divided by 2ab. Then we have minus 10a squared b, and we'll divide by that 2ab. Then we have plus 5ab divided by 2ab. So what is our answer? 6 divided by 2 is 3. For our a's, we have 3 minus 1, we get 2. For our b's, we have 2 minus 1, which is just 1. Then we have negative 10 divided by 2, we get negative 5. For our a's, we have 2 minus 1, we get 1. And for our b's, we have 1 minus 1, so we actually divide to make 0. Then we have 5 over 2, that's just 5 over 2. A over A is 1, B over B is 1. So this is our answer. I went a bit quick there. If you like, rewind it a bit so you can watch it one more time over if you feel like you need to. And you can erase my little marks and focus on whatever you think you should focus on first. Now, what about when your divisor is not a monomial? When the divisor has more than one term, we use a procedure very similar to long division in arithmetic. So let's recall long division in arithmetic. What if we had 3 divided by 61? Well, you would divide. How many times does 3 go into 6? Or 6 divided by 3? You get 2. Then you multiply 3 times 2, you get 6. You subtract. You get 0, you bring down your next one. You get 1. How many times does 3 go into 1? It doesn't, right? So then you have a remainder of 1. So you write your answer as 2 and a remainder of 1, or you can write it as 2 and 1/3, right? That same idea follows. So say we want to divide, in example 2, 3x squared minus 4x minus 15 by x minus 3. Okay, well, we follow the same procedure as long division. So let's go ahead and write x minus 3 on the outside. Now on the inside, we're going to write 3x squared minus 4x minus 15. Now I want to start off the same way. You want to divide your first number. So we have 3x squared, and you're going to divide it by the x. So it's like dividing by a monomial. So we have 3 divided by 1 is 3. Then we have our x's, 2 minus 1, we get 1. So it's just 3x. we go ahead and write 3x there. And then you repeat the process of multiplying. But instead of multiplying to just one number, you multiply to two numbers. So you have 3x times 3x. That gives you 3x squared. And then 3x times -3, -9x. Okay, just like before, you're going to subtract. But you're subtracting the entire number, or in this case, the entire expression. So what you can do is just change the sign of each one. So 3x squared minus 3x squared is 0. And actually, you should always get 0. Then we have -4x plus 9x. You get plus 5x. Then you bring everything down. Okay, let's do this again. So you're going to divide your first number. Five x divided by x. Let's show the work on the side. 5x divided by x. X divided by x is 1, so we're just left with 5. So plus 5. Now you want to repeat the process, and you want to multiply that 5 to everything on the outside, by the divisor to be precise. 5 times x is 5x, and 5 times -3 is -15. Okay, now you change the signs of your terms. So the first one's a plus, now it's a minus. The second was a minus, now it's a plus. 5x minus 5x is 0. And -15 plus 15 is 0. So we're done dividing, and there's no remainder. What is our answer? What we have above. Our answer is 3x plus 5. Take a moment to look it in. When you first see it, I remember when I first learned how to do this, it seemed pretty overwhelming. But after trying it once or twice, it's really enjoyable. So give yourself a chance to practice it a couple of times. Let's do another example. 5x squared plus 2x minus 14 by x plus 4, and we wish to divide. So we have x plus 4, and we're dividing that into 5x squared plus 2x minus 14. Okay, so let's start off by looking at those first numbers. We have 5x squared divided by x. Let's show the work on the side. 5x squared divided by x. So we have 5, and 2 minus 1 is just x. So we have 5x. Now we wish to multiply that to the outside. So 5x times x is 5x squared. 5x times 4 is plus 20x. Okay? Let's figure out what happens. Let's change the signs of what resulted from distributing that 5x. That was a 5x squared. Okay, so 5x squared minus 5x squared is 0. You should always get 0 for your first term. If you don't get 0, you made a slight mistake. Take a step back. Then 2x plus minus 20x is negative 18x. Then you bring everything that you have left over down. Let's repeat the process. So that we have negative 18x divided by x. So we have negative 18x divided by x. My x's divide 2 don't make 1, we're left with negative 18. Okay, now we distribute. Negative 18 times x is negative 18x. Negative 18 times 4, we get 72. So negative 72. Okay, let's go ahead and subtract this. So this minus is now plus, and this minus is now plus. So we are left with negative 18x plus 18x is 0. And that's good. We always want to start off with the 0. And we have negative 14 plus 72. we get 58. And we're done because I can't clean up 58 divided by x, right? So we're done, and this last number is our remainder. So how do we write our answer? Well, our answer is 5x minus 18. And how do we deal with the remainder? We write a plus, and we're going to write our remainder on top, and our divisor on the bottom, x plus 4. And that is our answer. Next example. Example 4. Divide 32x cubed minus 6x plus 12 divided by 4x plus 1. Okay, so we're going to set this up just as before. We have 4x plus 1. And we're dividing that into 30x 2x cubed. Now, what makes this different from the other problems is that you need to have every degree. So every degree is represented. So if I start with the x to the 5th power and you have a 4th power, 3rd power squared, 1st power, and then your number, your constant. So every degree needs to be there. So every degree needs to be represented. So here we have an x to the 3rd power. I would want then an x squared, which we don't have. So we need to make up for it, at least for a placeholder. So I write plus 0x squared. So I write plus 0x squared. Okay, now we continue. We have a x, so we write minus 6x plus 12. We need to have every degree there. If not, we write a 0 placeholder. Okay, let's go ahead and start this off. So let's divide 32x cubed by 4x. So we have 32x cubed divided by 4x. 32 divided by 4 is 8. And x cubed minus 1, we get x squared. Eight x squared. Let's go ahead and multiply it by the divisor. So x squared times 8x squared divided by 4x, or sorry, multiplied by 4x, we get 32x cubed. And 8x squared times 1, we get 8x squared. All right, let's go ahead and subtract. So we change the sign of each term. And every term we get a 0. And then we're left with 0 minus 8, we get minus 8 squared, 8x squared. And then we bring down all of our numbers. Yeah, you can bring them down all at the same shot. Okay, let's repeat this again. So let's divide 8x squared negative 8x squared by 4x. Negative 8x squared by 4x. We get negative 2x. So we get negative 2x. Okay, let's go ahead and show the multiplication. Let's multiply it in. We get 4x times negative 2x, we get negative 8x squared. Negative 2x times 1 minus 2x. We subtract. So now we have a plus and plus. And we have negative 8x squared plus 8x squared, we get 0. Negative 6x plus 2, we get negative 4x. Then we bring down the 12. Okay, we do this one more time. Okay, we divide negative 4x by our divisor, which is 4x, and we're left with negative 1. Okie dokie. Let's go ahead and multiply that in. Negative 1 times 4x is negative 4x. Negative 1 times 1 is negative 1. We go ahead and find the difference. So now that's plus and that's plus, and we're left with 0 plus 13. And that's our remainder. So what is our answer? Our answer is 8x squared minus 2x minus 1 plus 13 over 4x plus 1. There we have it. Now, long division polynomials with practice is enjoyable, but there's also a helpful trick to dividing. This is called synthetic division. It is important to remember that in order for synthetic division to work, the divisor must be of the form x minus a. That is the variable minus the constant. The coefficient to the divisor of the variable must be 1. So how we do synthetic division is you're going to take the number opposite of the sign. So I have a minus 4, I'm going to work with 4. And if you're unsure why this happens, we're technically working with the answer, the solution, the 0. So if I have x minus 4 and I solve for 0, plus 4, we get x equals 4. So that's where that 4 comes from. Okay, now we're going to divide by 4. Now for synthetic division, we want to only work with the coefficients. So here, my coefficient would just be the 2. Here I would have a negative 1. Here we have negative 43. Here I have a 60. And you want to make sure every degree is represented. If not, write a 0 placeholder. So we're going to use those numbers. A 2, a negative 1, a negative 43, and a 60. Okay, to begin, let's go ahead and your first step is to bring down your number. So we have 2. And from there, you're going to multiply and add. So we're going to multiply 4 times 2, you get 8. And then we add them. Negative 1 plus 8 is 7. Okay, now I want to multiply 4 and 7. 4 times 7 is 28. Then we add them. Negative 43 plus 28, that gives us negative 15. Repeat the process. So we multiply, then add. Multiply 4 times negative 15, you get negative 60. 60 minus 60 is 0. Your last number is always your remainder. So in this case, our remainder is 0. And our answer is coefficients. Now there's two ways to think of this. If your exponent, your highest exponent is a 3, your answer will start with the x squared. How I like to think about it is you start with no x, and keep going one more x. So in this case, we have x squared. So our answer to our question, to our division, is 2x squared plus 7x minus 15. Let's do this one more time. Okay, so here we're going to divide by, so in college algebra they call it a C. So our C is negative 5. Remember, it's always the opposite. If you have positive 5, you work with negative 5. Now here you want to take your coefficients, and you want to make sure every degree is there. So here I have a fourth power, third power, squared. I need an x. So right here I need to remember to add a 0 placeholder. So now let's look at the coefficients because we want to work with our coefficients. We're going to work with a 1, a 1, a -9, a -7, a 0, and a 10. So for our synthetic division, we're going to set it up by dividing with a -5, and our numbers are 1, -9, -7, 0, and 10. Now you want to remember, this last number is always your remainder. Now in our last case, it divided evenly, so our remainder was 0. Now what are your steps? Your steps are always to, first you want to bring down the first number, and then what you do is multiply, then add until you're done. So this is the important thing. Multiply and add, multiply and add. Okay, so let's bring down our first number. 5 times -1 is -5. We add them, we get -14. 5 times 14 gives us 70. Negative times a negative is positive. All right, so -7 plus 70 is 63. 5 times 63 is 315. -5 times 63 is -315. Plus 0 is just -315. And then 5 times 315 is 1575. Plus 10, 1585. That's our answer. So remember, no x, x, x squared, x cubed. Our answer is x cubed minus 14x squared plus 63x minus 315 plus 1585 over our divisor, which was x plus 5. Synthetic division is really helpful, and it plays a very important role in college algebra. That's it for 5.3, division of polynomials. Thank you.